Now in this problem, we will be learning how to do addition and subtraction of vectors using the component methods. Let's take a look at this question. Now, there's a ship initially cruising in the direction bearing of 45 degrees at a speed of 10 meters per second, and it changes direction to head in a new direction bearing of 145 at a speed of 5 meters per second, as seen in figure 1. Now, when the maneuver was completed in 30 seconds. Use a vector diagram, or otherwise, let's calculate the acceleration of the ship during the change in direction. So there are a few things to take note. First of all, we need to identify where are the vectors. So let's identify the vectors. Okay. Well, there's this vector A, indicated by this arrow, and vector B. These two. And take note, we need to find the change in direction. So remember, we are dealing with vectors, we are not dealing with scalars. So it is very important that we are dealing with the subtraction of vectors. All right, let's denote the change in velocity with delta V. And delta V is equal to the final velocity minus the initial velocity. So change in velocity is denoted by final velocity minus initial velocity. But how do we do a subtraction of two vectors? Actually, we add them in this manner. Final velocity plus the negative of the initial velocity. So let's place the final velocity and the initial velocity as stated in the question. So the final velocity is B, vector B, plus the negative of vector A. Now how do we write vectors? We write vectors with an arrowhead on top of the symbol. Okay, so now we have settled the notations for subtraction of vectors. We need to proceed further to do the resolution of the vectors. So what I'm going to do now is I'm going to resolve vector A in the negative direction. So just let me draw. Okay, suppose negative A is in this direction. Right? This is negative A. All right, the initial velocity in the negative direction. And we resolve in the corresponding X and Y component, which is the horizontal and the vertical component respectively. So let's resolve in this manner. Okay, this will be the horizontal component AX and the vertical component AY. And the angle respect to the vertical is 45 degrees. Alright, so what is AX? AX, its magnitude is 10 because the speed is given as 10 meters per second, so the horizontal component will be given by 10 sine 45 degrees. Alright, why? Because this AX component is actually the opposite of this triangle you see here. Okay, where's the triangle? Oh, let me highlight the triangle for you. There's this triangle here. Alright, it's opposite. So it's 10 sine 45. Now what about the vertical component? Now the vertical component will be 10 cosine 45 degrees. Alright, 10 cosine 45 degrees. So these two components are found. Let's proceed to resolve vector B. So we're going to do the same thing, resolve vector B in the horizontal direction and the vertical direction. Okay, so this will be Bx and this will be By. All right, take note, the speed has changed to 5 meters per second, so that's why the length of this vector B is slightly shorter. The length is shorter compared to vector A. Okay, so how are we going to calculate Bx? All right, the angle is 35 degrees for this side. Okay, angle of a straight line is 180, so you take 180 minus 145, you get 35 degrees. And Bx, okay, since the speed is now 5 meters per second, so we say it's 5. This will be sine 35 degrees. And for By, it will be 5 cosine 35 degrees. So the four components are found. Take note the components are drawn using dotted lines to represent their components. And actually, we should include the arrowhead for the four symbols, which is AX, AY, BX, BY, but we did not do that because it is understood that AX, AY, BX, and BY, they are vectors. So now we need to proceed to add all these components. Now we can only add components in the same direction. So let's deal with the X component first. So I will do it here. So for the X components, all right, we can only add the AX and the AY together, and the BX together. So we AX plus BX. Now, the directions of these two vectors, AX and BX, they are opposite. So we'll follow the number line. So AX is in the negative direction of the number line, while BX is in the positive direction of the number line. So I'm going to give a negative value for AX, which is negative 10 sine 45 degrees. BX is in the positive direction, so it will be 5 sine 35 degrees. That is for the X components. So I'm going to find the sum of the X components. So after adding, by using the calculator, I found that the two add up to minus 4.2. Now, let's do the same for the Y components. Now this time we'll be adding AY and BY. Now, these two components, they are in the negative Y direction. So the two values, you must give the negative sign to indicate it is in the negative direction. All right, so AY will be a negative 10 cosine 45 degrees. All right, plus BY in the negative direction, which is minus 5 cosine 35 degrees. Adding up the two, you will have negative 11.2. Now, all these vectors has units. What's the units? The units is in meter per second. So do not forget to include the meter per second for both components. All right. So now we have added up the components in the appropriate directions. We will now move on to calculate the acceleration. So how do we proceed further? Stopping at the components is not enough because we have not found what is the change in velocity here. We only deal with the components. So let's proceed. All right. So we got the components already. So then we will have change in velocity, which is actually change in Vx whole thing square plus change in Vy square whole thing square root. This is using the Pythagoras theorem, all right, to calculate the magnitude of the change in velocity. Now you may wonder, what is the change in Vx and change in Vy? You got it already. Remember, we add the x components. The x components added up together is the change in Vx. So previously, the answer was minus 4.2 squared. Then the change in velocity in the y direction is minus 11.2 squared. And whole thing you square root. And you found that the answer is 11.9 meter per second. So the change in velocity, its magnitude is 11.9. From the magnitude, we can calculate the acceleration. What is the formula for find acceleration? Change in velocity over time. And we have found the magnitude of the change in velocity, which is 11.9. Now the duration where this change in velocity occurs is 30 seconds. So calculating, you will have 0.40 meter per second square as your acceleration. But can you stop here? No, you can't stop the magnitude, because acceleration is a vector. You need to indicate the direction of this acceleration. So how are you going to calculate the direction? Easy. Let's theta be the direction, and it's actually equal to this formula. All right, change in Vx over change in Vy. Inverse tangent of this ratio. So let's put it in. 4.2 over 11.2. And you find that the answer is 20.6 degrees. Now you may wonder, how do I get this ratio? Why is it change in Vx over change in Vy? All right, if you remember, our sum of the horizontal components is in the negative direction. So let me plot out. Let's say, okay, my Vx, change in Vx, remember the sum is minus 4.2. So it was minus 4.2 here for Vx. All right. Then your Vy is also in the negative y direction. The change in Vy is negative 11.2. So your resultant velocity is in this direction. Okay, this is your change in V. Now the angle we are finding, the theta, this 20.6, where is it? All right, is with respect to the vertical. This is the angle we are finding, theta. All right, this is the angle. What is the triangle we are focusing is this one. Okay, opposite over adjacent is equal to tangent theta. Right? So 20.6. So with this direction found, you can say that the acceleration occurs at 0.40 meter per second square at an angle 20.6 degrees to the vertical. But since the question is given in terms of bearing, we have to find the bearing of angle theta. So the bearing of A All right, so how do we find the bearing? So let's say bearing is measured from the north. So it's actually this whole angle here. Okay, this whole thing. Let's highlight, maybe using blue. So this angle you need to find. All right. So it will be 180 degrees. All right, plus theta. So 180 plus 20.6. So your bearing is actually about 200.6. All right, 200.6. But let's round it off. It will be, let's say, 201. So with this, we have solved the problem. We found the magnitude and the direction. The bearing is 201. Well, I hope this question has enhanced your understanding of vectors, and I wish you all the best in solving subsequent vector problems. Thank you.